I would like now to move on to the Fatigue4Light project, which will be presented by Ms. Maria Violeta Vargas from Eurecat, and she'll be talking about the strategy on LCA for that project.
Yeah, let me share my screen, and thank you both of you for presenting me, Francesca and Jose, since you both presented a bit who I am and where I work. As they said, I work at Eurecat, and we are part of both projects, FLAMINGo and Fatigue4Light for now. And well, for now, I'm going to present a little bit what we do on the LCA strategy for Fatigue4Light. First, I'm going to explain a little bit what it is, what we're doing on Fatigue4Light project, what are our main objectives, and what we're studying. And then I'm going to present a bit of what we've done applying life cycle thinking and the eco-design methodology, and then the scope and functional unit system boundaries, more directly on the LCA approach. And then how we're doing on the LCA data collection that we all know is kind of a hustle. So Fatigue4Light has a few main objectives, which is a weight reduction of 24 to 30% of this weight. Also is aiming for weight savings from structural vehicle weight of 12 to 15%, which will also increase the electric vehicle safety due to reduced front mass. We are also aiming to find material solutions with high fatigue performance, such as advanced high strength steels, stainless steel, aluminum alloys, and hybrid materials with fiber polymers materials, to develop also a new computer modeling with high fatigue prediction accuracy, new experimental methodologies that can reduce the testing time for these new materials, and then more on our side of LCA or life cycle thinking, we are looking for an enhanced affordability and sustainability that is based on eco-design or design for circularity, supported by the studies of life cycle assessment and life cycle costing. So for this project, we are on the life cycle thinking part, we are doing design for circularity, life cycle assessment, and life cycle costing all at the same time, and all throughout the project from the beginning. We are studying this, just like FLAMINGo, that has a few demonstrators to prove all these developments. We are studying these 4 demonstrators, which is the lower control arm, the crossbeam member, the wheel, and a lab scale demonstrator to prove the different materials that we're trying on this project. So the LCA is going to be applied to all these demonstrators with the different materials as well. And for this, at Eurecat, we developed a new methodology for eco-design or design for circularity some time ago, and we applied it to different projects that we are working on. One of these projects is Fatigue4Light, the other one is Marble, but we're not presenting that one here. For Fatigue4Light, we use this methodology that follows 4 simple steps that actually are following the Deming cycle, which is known by a lot of us, and it's like easy to think about it. So it's plan, do, study, and act. And following this methodology, well, we have 4 steps that are easy, where we identify different hotspots or the aspects that we have to really pay attention to, that we're going to get really bigger results than others. Then to establish different strategies based on eco-design and based on what we found on step 1. After this step 2, where we have the strategies, we have to readapt the strategies to the technical aspects and requirements of whatever we are designing. And then on step 4, we define concrete and specific actions, eco-design actions to apply. A little bit more in detail, on the first step, what we do is based on a benchmark analysis and on a simplified and preliminary LCA and LCC, after having these results of this preliminary and simplified LCA and LCC, we can identify these hotspots and the life cycle stages, and then correlate these hotspots with the life cycle stages to find like where we have to pay attention to. And after having this hotspots defined, then we can define the strategies that we're going to go to. In this project, since our main objective is lightweighting, then we focus mainly on it, but we also try to pay attention to other objectives like design for maintainability, lifetime extension, to find substitutes for critical raw materials, and to consider second market resources for this. So after going through step 2, we have a repository of strategies in a datasheet format that we can actually apply to other projects as well, as long as they're electric vehicles projects. So having this repository of strategies, we had a webinar or workshop where we invited all our partners from Fatigue4Light, and we try to familiarize everybody with the eco-design concept so we can came up with more ideas and to readapt the strategies that we had at the beginning, to readapt them to the technical aspects and requirements that only the technicians can know. So then we had a different set of, well, not different, but a more accurate set of strategies. And after the strategies, we defined specific actions to go through throughout the project, as well with all the partners that were participating in the webinar. So after having a list of different specific actions that we can go through, we also applied an analytical hierarchy process, which is a methodology to rank things, like to put them in order, which one is more important or more feasible and viable and important at the same time. So with all the partners, we ranked these actions, and we got like a list of actions that we have to follow through. And also that since they're ranked, then we can identify the most important ones. So we came up with this list. Over here, you can't see the list in order because we wanted to show you the strategies and the actions at the same time. So you can see here on the left, the list of the strategies that we were considering. And then we have the list of the specific actions that we're going to go throughout the project to get better results in circularity and environmental impact, hopefully. Then we have to do another LCA and LCC and compare the results with the first ones or preliminary LCA and LCC that we started with. So then with the AHP, well, the analytical hierarchy process, we have a score for each of the strategies, and then we did the same for the actions, and we have a score for the actions over here, and then a final score combining the two previous ones. And then with that score is the one that helps us put the actions in order. So, well, that's for the eco-design methodology. And then to show you just the scope that we are following in Fatigue4Light, we have 3 life cycle stages considered in this project. We have one that is raw material extraction, manufacturing, and assembly. Then we have the use phase and the end of life. Of course, we are following a cradle-to-cradle approach on this project. And for this, we have, well, a functional unit of 1 kilometer. And we have this system boundaries that are like, this one that you can see on screen is very general. All the processes from raw material extraction, manufacturing, and assembly will be specific for each of the demonstrators once we have the inventory for each of them. But just to show you, this is the general one for all the demonstrators in the studies. I think I have nothing else there. And then right now we are collecting the data for both the LCA and LCC at the same time. We've been sending this template to all our partners and getting some answers from them. Sometimes it's easier and sometimes it's kind of hard to get an answer. And other times it's hard to fill in this table the right way, but we're working on it. We have a very good consortium, so we're all working on it. They're all implied in it, thankfully. So after having all this data, we have all this data for the first stage, that is raw material extraction, manufacturing, and all this. And then we have the use stage and the end of life stage that are going to be based on literature. For the use stage, we're going to use these two references, which is one of from the CSA group. I think we all know it. It's for auto parts in general. And then there's the European Environment and Agency document or guidelines as well that are specific for electric vehicles. So we're going to use these two for the definition of the use stage, which is going to give us the lifetime driving distance and the energy consumption throughout the life. And then for the end of life stage, we also have to define the different percentages for recycling, landfilling, and energy recovery based on literature for this too. After applying this this eco-design methodology and the LCA at the beginning and all, we have found that, again, the LCA data collection is challenging. It's been a hustle, and it still is. The difficulties, again, here is the definition of the use stage and the end of life, because it's always kind of, it's accurate to get a definition from literature, but it's still, we are worried that it's not real at the moment that this information is applied. If we applied it right now, I'm sure it's going to be more or less real, because this literature will be up to date, but at another moment it will be different. As always on LCA, this happens often, but still, it's a worry. And then from applying the eco-design methodology, we found that we could find a very useful list of actions to go through throughout the project. So we found it very useful. So that would be it from my side.
Thank you very much for your presentation.